So, CriticalThink has admitted that he doesn't know the difference between great circles and small circles, which are also called latitude lines, on his sphere Earth. He seems sincere enough. I would like to help him, so hopefully we'll be able to do that here today. Real quick, if you haven't subscribed, go ahead and subscribe. And if you want a thumbs up, go ahead and thumbs up. And if you want to support the channel, there are some links in the description, and there's also something called Super Thanks. Okay, stay tuned till the end because I have a little blooper at the end too. All right, let's go.
Now, p-brane likes to say that all great circles are straight lines and latitude lines are turns. Now, some of the literature does sort of say that, but to me, they're all circles, right? Every one of them is a circle. So why is one turning and the other one not? I don't get it. So why is one turning and the other one not? I don't get it. I don't get it.
So this is for you, CriticalThink. You said you didn't understand the difference between a small circle and a great circle. To you, they're just circles, right? So here we go. Here's a sphere. And in spherical geometry, this is what it says. The geometry of a sphere, known as spherical geometry, focuses on the properties and figures located on the surface of the sphere. That's what you're missing. You're just saying a circle, a drawn circle, a circle is a circle. You don't see how one is a turn and one you traverse straight. One you traverse in a turn, the other one you traverse straight. You don't see the difference, okay? Here we go. You're gonna get it after this, for sure. You better. All right. Just like my rotating platform, the blue one, I'll show you that in a second. This is rotating east, this ball, right? Okay, this arm right here, this is a tangent to the rotation or at a right angle. Everything moves at a right angle to that. That's how it starts anyway. Now, this is a straight line called a great circle. I've gone over great circles a lot. It's the largest circle you can draw in a sphere, and you traverse it straight. Here's my little Lego person. They would traverse it like this. Okay, and my little Lego guy represents water, right? So I have a person because I want you to see the orientation of people on the surface. This is all about the surface of a sphere, which is perpendicular to the center. And we, standing on the sphere, would also be perpendicular to the center of the Earth. This latitude line, here like maybe 70 degrees north latitude, representing the ground, is a turn, turn. Now you have to keep looking at the surface. Try to be perpendicular to the surface so you can see. That's a turn. This one, great circle, is straight. As per Newton's first law of motion, everything wants to go in a straight line. So this, say it's about 400 mile per hour moving water, rotating, wants to go in a straight line. And as far as being on the surface, there are actually like two frames of reference. You have the non-inertial frame. That means the one that's not still, but actually the one that's moving in your model is the Earth. So from that frame of reference, all you would see is this latitude line represents the ground, and it is separating. Both are moving, let's say 400 miles per hour. The blue represents the water, the blue line. You would see the water moving south as you're standing on the sphere. Now, looking at it from above in the inertial reference frame, which means still non-moving, that would be space, you would see this whole thing moving together, but you would still see, it would almost be like spiraling, but it would be moving together and you would see the water separating from the land until it hits either the bank of whatever's holding the water, a Great Lake or ocean or a pond, whatever, or it would collide at the equator with all the stuff from the south would do the same thing. Okay, so your cylinder idea is this. So I put this on here. Now this is this is a cylinder. This is what you're saying. Now remember, your lines, or your circles, your circles are slices of a sphere. So it has the surface of the sphere. They're not cylinders, as you tried to make out. This person would have to walk this way around, or actually she has skates on, would go this way, all the way around the sphere. Well, that's not how you traverse a sphere. You're not at this angle. We're not at that angle to the sphere. No, we're at this angle. You have to take the ground. So get that out. We're not that. You traverse it like this. And this is a turn. All the way around. Just like if you laid a hula hoop down at the North Pole, clearly you can see this is a turn. Okay, so clearly you can see this is a turn. Right? So, yes, you can look at a latitude line like this and say, oh, it's a straight line. No, it's not a straight line, because you have to take the surface into account. You traverse a different part of that line because it's a slice of a sphere, because it's a slice of a sphere, because it's a slice of a sphere, not just a circle. Well, I'll take it like a hula hoop. Right? Now, if you traverse the hula hoop this way, that's a great circle. You traverse it like this. That's a great circle. That's at the equator. That's the only place the ground would have you traversing in a straight line. As you move up, you start to move onto this side, and you travel like this. And then when you get to the North Pole, now you're traversing in a circle. Right around, you go all the way around in a circle. See how that works?
Now, p-brane likes to say that all great circles are straight lines and latitude lines are turns. Now, some of the literature does sort of say that, but to me, they're all circles, right? Every one of them is a circle. So why is one turning and the other one not? I don't get it.
All the way around, just like if you laid a hula hoop down at the North Pole, clearly you can see this is a turn. It goes around. Shoot, all I can see is my hand. Just knocked her hair off. This is a disaster. It's not really going as planned here. How's her hair go? Oh, it's like that. Ponytail. Android battery is low.